So in this part of the lesson, what we'll be doing is we'll be talking about adjoint. Okay, we'll find the adjoint of A and we'll find the inverse by using the adjoint of A. So here is example 3. Find the inverse of the matrix A. You already know how to find the inverse from the previous section by using the echelon form method. What we did there is that if A is given, so 2, let's say 2, 1, 1, 1, negative 1, 4, 3, 1, negative 2, then what we will do is we'll write the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1, and then we switch the identity matrix from here to there, and then whatever will be the result on the right hand side when we try to change this, when we try to change the left hand side into identity matrix, whatever result we get on the right hand side, that is the inverse, right? That's the method that we already discussed. And today we will learn a new method to find the inverse of a matrix. All right, so inverse of a matrix. Let's look at this example 3. Find the inverse of the matrix by using adjoint, by using this, by using theorem 8, by using this formula. By using formula A inverse equals 1 over determinant of A adjoint of A, or adjoint or adjugate. So this is actually adjoint A. In short, we'll write ADJ A, okay? So that's the full form, adjoint A, and in some book, it's written as adjugate as well. It's the same thing. Okay, using that. So I trust that you know how to find the determinant. So let us find the determinant first. So determinant of A is 2, 1, 1, 1, negative 1, 4, 3, 1, negative 2 equals, I trust that you can calculate this by yourself. Okay, this will be, I believe, it will be, I think, 14. But I want you to verify that my answer is correct, okay? Okay, now let us find the adjugate. In order to find the adjugate, first we'll find the cofactor matrix. By the way, what is adjugate is, adjoint matrix A is actually the transpose of a cofactor matrix, okay? This is transpose of cofactor matrix. Okay, what that means is we'll write C11, it's all cofactor, C12, C13, C21, C22, C23, C31, C3, third row, second column, third row, third column. Transpose of this matrix is called the adjugate of A matrix. Okay, that's the definition, remember. All we need to do is we need to find the cofactors, all of these cofactors. Let us calculate all the cofactors there. So to find the cofactors, now we need to find cofactors. Let us calculate C11. C11 means you see the sign will be positive, right? Because 1 plus 1, actually it is negative 1 power 1 plus 1, whatever there is. I think we discussed that in our earlier class. So that will be positive. I simply write positive. Anyway, I can write that way too. And what it means is we ignore the first column and first row, and whatever is remaining, we write this as a determinant. So basically, we ignore the first row and first column. So the remaining is negative 1, 4, and 1, and negative 2. And so if you calculate this, you're going to get negative 2. That is your C11. In the same way, let us calculate C12, first row, second column. So that will, the sign will be negative 1 and this 1 plus 2, okay, row plus column. And then what it means is you ignore the first column, sorry, first row and second column, and whatever is remaining, write it down. So that will be 1, 1, 1, negative 2. So if you calculate this guy will be negative, and this is negative 2 minus 1, negative 3, negative, negative, positive 3. Okay, in the same way, let us calculate first row cofactor for first row and third column, which will be negative 1 power 1 plus 3. And so it means ignore the first, okay, delete first row and third column, first row and third column. And so the remaining is 1, negative 1, 1 and 4. So if you calculate this, you're going to get 5. Okay. In the same way, there are 9 cofactors. You need to calculate all of those 9 cofactors. So now let us calculate second row, first column. So that's going to give me negative 2 plus 1. And so I ignore the second column, second row and first column. Second row and first column. So the remaining is 1, 3, 4, and negative 2. And if you work it out, you're going to get, I believe, negative 14, no, positive 14. And then in the same manner, C22, which is negative 1 power 2 plus 2. And so you ignore second row, second column, so that you will have 2, 3, 1, negative 2. And if you work it out, it will be negative 7, I believe. If my calculation is wrong, then just let me know. And this will be second row, and you'll get negative 1, 2 plus 3. So we're gonna ignore second row, third column. So we'll have 2, 1, 1, 4. And if you work it out, you will get negative 7 again. Okay, now 3 more. Third column, third row, first column. So it will be negative 1, 3 plus 1. And so that's going to give me third row, first column. So you left with 1, 3, negative 1, 1. And if you calculate, you're going to get 4. And C3, 2, it will be negative 1 power 3 plus 2. And so you ignore third row and second column. So you'll get 2, 3, and 1, 1, which is 1. And C3, 3, which means negative 1 power 3 plus 3. And so you ignore third row and third column, left with 2, 1, and 1, negative 1. And if you calculate this, you're going to get negative 3. So adjoint of A, so adjoint of A equals transpose of the cofactor matrix, okay? Transpose of cofactor matrix, which means, let us write down the cofactor matrix first. So cofactor matrix is C11, which is negative 2, C12 is 3, and then 5. Okay, I write down the, all the element in the first row, and let us write down the second row, which is negative, which is 14, negative 7, negative 7, and the third row will be 4, 1, -3, and you transpose it. That is the cofactor matrix, and we need to transpose it. So if you transpose, the vertical will change into horizontal. In another word, the row will change into column, column will change into row. So that means your adjoint of A, I forgot to write A here, adjoint of A equals, so that's going to be -2, 3, 5, 14, -7, -7, and 4, 1, -3. Okay, if we transpose it, that's what we're going to get. Do you have any questions so far? Okay, now we want to find the inverse. So the inverse is, the formula is, we know the formula. So A inverse equals 1 over determinant of A and adjoint of A. That's the formula, okay? The proof is not required. Proof of the formula is not required for this course. So 1 over determinant of A is 14, and adjoint of A we just calculated, which is -2, 3, 5, 14, -7, -7, 4, 1, -3. Okay, so you can just write that way, or if you want, you can actually, write down this -2 divided by 14, and so on. So if you divide everything, this is a matrix, this is not a determinant, okay? For matrix, you have to divide everything here by 14, every column and every element in the matrix. So if I divide that, I'm going to get -1 over 7, because -2 over 14 is 1 over 7, 14 over 14 is 1, 4 over 14 is 2 over 7, and this guy is 3 over 14. This will be -1 over 2, and this is 1 over 14, and this one is 5 over 14. This will be -1 over 2, -3 over 14. That's it. That is your inverse. Okay, you can check your answers by finding the inverse from the other method that we learned in the previous chapter. Okay, so with this example, we learned two things. One, what is the adjoint matrix? So adjoint matrix means it's the transpose of the cofactor matrix. And we also learned that we can use the adjoint matrix to find the inverse, and for which the formula is A inverse equals adjoint of A divided by the determinant of A. Now, if determinant of A is 0, and we already said that the matrix is not invertible, you cannot find the inverse. And the good news is the determinant is not 0 here. That's why we're able to find the inverse of the matrix. Any questions so far? Now, I want you to try one question just for fun. Look at this example 4. In our last class, what we did is we solved this system using the Cramer's rule. Now, part B says that solve the system by first finding the inverse of A and using theorem 8, the formula AX equals B, that is X equals A inverse B. So what I would like you to do is find the A inverse by using the adjoint. Okay, find A inverse by using the adjoint of A, and then use this formula. So let us try that just for fun. I'm gonna erase this. Okay, no, let's try this here. Part B. So here A is, okay, the system here, A means coefficient matrix. So A is coefficient matrix, which is What is A? 5 to 4, negative 2, 5 to 4, negative 2, 3, negative 5, 3, negative 5, 6. This is our coefficient matrix, right? Did I copy the right thing? Yes. Okay. Now I want you to find the first determinant of A. So determinant of A, I believe we already calculated that. Determinant of A is, we calculated this in our previous class, which is negative 37. Okay, let me just copy that down. Maybe what I can do is, I will just bring this all the way there. Okay. A little bit up there. Determinant we already found. Let us find the cofactors. Okay. To find adjoint of A, we first find cofactor matrix. So for which, let us find cofactors. C11, C12, C13, C21, C22, C23, C31, C32, C33. I want you to calculate all of these just for fun. I will wait for you guys, okay? Take time and yeah, try to get all the values. Okay, thank you very much for helping me to calculate all these cofactors, all the 9 cofactors here. So we have C11 is negative 7, C12 is negative 32, 13 is negative 22, C21 is negative 3, C22 is 18, C23 is 17, C31 is 1, C32 31, C33 is 19. So our adjoint matrix is, adjoint A is transpose of the cofactor matrix. Transpose of cofactor matrix, which means cofactor matrix, let me write it down, negative 7, negative 32, negative 22, and negative 3, 18, 17, 1, 31, and 19. So, and then transpose, don't forget to transpose it. So the answer is negative 7, negative 32, and negative 22, negative 3, 18, 17, 1, 31, and 19. And that is our adjoint of A. Now let's find the inverse. So formula is A inverse equals 1 over determinant of A, adjoint of A. So 1 over negative 37, and this guy will be negative 7, negative 32, negative 22, negative 3, 18, 17, 1, 31, 19. Okay, we got A inverse. Now, using the, look at that, it says that use this formula in part B. We are required to use this formula, AX equals B, which means X equals A inverse B. Okay, X equals A inverse B. So let us use that formula. So to use the formula, and X equals, okay, I need more space here. Let me go there. So X equals, or you can say we know X equals A inverse B. So A inverse is, there we go, 1, negative 1 over 37, and then negative 7, negative 3, 1, negative 32, 18, 31, negative 22, 17, and 19. And then B is, okay, B is the constant term, which is 16, 2, and 7, I believe. Is that right? 16, 2, and 7. Let's go all the way there in the system of equation. So 16, 2, and 7. Yes, that is the constant term. So I wrote that correctly. Okay, all you need to do is you multiply this. Okay, negative 1 over 37, and then you multiply this 2. So does the multiplication exist? This matrix is 3 by 3, and this matrix is 3 by 1. So if yes, multiplication exists, and the resulting matrix will be of this size. So if you multiply these two matrices, I trust that you'll be getting 1, 1, 1, negative 2, 5, 9, and negative 1, 8, 5. Okay, please multiply these two matrices and you're going to get that. So therefore, this is going to be negative and negative positive 1, 1, 1 divided by 37, and 259 divided by 37, and 185 divided by 37. So that's going to give you how much is that? 3 and 7 and 5. So what we got is X equals, X is actually X1, X2, X3. There are 3 variables, and we got 3, 7, 5. Okay, so what does that mean? This means your X1 is 3, X2 is 7, and X3 is 5. Any question? So we learned so many methods to solve the system of equation, right?